Hello everyone, my name is Marton Hablicek and today we'll talk about Master of Mathematics. I'm a study advisor here in Leiden and also an assistant professor. And today with me here are Dalia, Ono and Yulin, and we'll discuss aspects of the Master in Mathematics in Leiden. So yeah, this is us with Dalia. We are study advisors and assistant professors at Leiden University. And the program of today will be the following. We will talk about with Dalia about the master program. There will be presentations by Ono and Yolin afterwards. And in the end, there will be a Q&A where you can ask questions from us, and we'll try to answer the questions as well as it is possible. You can also send questions right away from now on. So please, if you have any questions, just send us. And in the end, we'll discuss the questions in the Q&A session. So let's start with the presentation. So why would you come to Leiden? There are many aspects to it. So first of all, the university was founded more than 400 years ago in 1575. And it has been a prominent scientific center of Europe. It is located between Amsterdam and The Hague. Both cities are basically 15-30 minutes away from Leiden, and it provides a nice international vibrant environment. As a student, you can also enjoy this vibrant environment, for instance, by joining study associations. There are more than 30 study associations in Leiden. You can join study associations including sport associations, music associations, cultural associations, religious or international associations. The physics, astronomy, mathematics and computer science students also have a study association called the Leidse Fles, and they organize study trips, excursions, lectures, parties, pub quizzes and all various activities, and they are also involved in running the FU bar, which is a bar in our department, which is a informal gathering space for both the faculty and the students. The study environment in Leiden is very free. The motto of the university is Bastion of Freedom, and this is reflected in the study environment. You are encouraged to follow your dreams, follow your own interest, to form your own free opinion, and then to develop critical thinking skills. The student-teacher interactions are usually less formal than what students are used to. And in small study groups, you can tailor your study plan individually. It's a unique experience in small study groups. Our academic staff consists of more than 60 people, and we have also more than 50 PhD students. We have more than 120 master students at present, which means that every year around 60 master students or 70 master students join our department. So it means that as many students join as the size of the faculty, and that provides an opportunity for you to have a one-on-one interaction with your professor of choice in Leiden. So it again provides you a very personal and unique experience, and you can study what you would like to study, basically. And Leiden itself is not just a prominent scientific center, but it also has ties with the international scientific community and with other disciplines as well. So for instance, we have the Lorentz Center in our building. This is a multidisciplinary center for scientific workshops, and it provides workshops on the entire scientific spectrum, so from physics, biology, chemistry, etc., etc. There are other consortia which Leiden is part of. There's, for instance, the Algand program. The name comes from algebra, geometry, and number theory, This is a consortia consisting of 10 research institutions on 4 continents, and it provides a 2-year master program where you can spend 1 year in Leiden and 1 year at another university. And this Algan program specializes in algebra, geometry, and number theory. If you are someone with a more application-centered mind, then we can also offer more application-centered consortia. The first one, the Quantum Software Consortia, is established by researchers from Amsterdam, Leiden, and Delft, and it deals with questions about quantum algorithms, quantum protocols, cryptography, and empirical physical problems related to quantum theory. There's the CWI, which is the Center for Mathematics and Computer Science. This is the research institute for mathematics and computer science in the Netherlands, and this is known for being the birthplace of the European Internet in 1988, and it's also known for developing the programming language Python. And if you are interested in networks, we are also part of the Networks Consortium, and then here people deal with questions about large-scale networks, how to optimize, how to control these large-scale, how to study these large-scale networks. And I give the opportunity for Dalia to speak.
Next, we are going to take a closer look to some practical information, and we are going to understand what are the possible specialization within the master programs. The first 2 are research, and the other 3 options are combination masters. The first 2, as the name says, are focused on research, and these are algebra, geometry, and number theory, and also applied mathematics. Now, applied mathematics doesn't really mean that this is very applied. Something like a very high-level analysis can also count as applied mathematics. The credits that you take in one of these, either applied or more pure, like algebra, geometry, and number theory, can count for both. Another possibility is to do a combination masters, and this, as the name suggests, you can take main courses in the research master and supplement them with 3 specializations. One of them is mathematics and education. The other one is mathematics and science communication and also society. And the last one is mathematics and business studies. It's possible to join the Leiden University, the master program at Leiden University, if you have a bachelor at some university in the Netherlands, or it's also possible to transfer credits from another European university. And for this, I follow this link here. So these are the main possibilities within the master program. And the next thing, we are going to look at the first possibility of combination master, which is mathematics and education. So here you see that the whole slide is in Dutch, and this is because this is specialized in education. So you are supposed to become a teacher to teach in high schools and schools within the Netherlands. And here you take bulk of master courses in the main master program, which you can supplement by taking special courses in education. And you have a possibility of following the classical master program with 120 units and then supplement it with 60 units at the end, if this is your decision. But you can also decide on pursuing an education career, and then you can opt earlier, and this is the second possibility to follow this education specialization. And then there are also elective classes, and for this there are links at the end. Okay, so this was about the possibilities of courses at Leiden University. Now the university is not only concerned only with your knowledge, with your mathematical knowledge, but it's also concerned about your personal well-being, about the possible career that you can pursue after graduating from a master, and also about exchanging experiences and launching some network events after graduation. So in the first part, student well-being, this is one way that the university takes care of the students. It might be that occasionally you need some additional support to boost your potential for focusing on your studies. And the study well-being personnel are well equipped to provide such support. For the science career service, there are regular workshops. There are several sessions which train you how to write up your best CV. You can also schedule consultations. You can obtain online information, and links for all these facilities are provided at the end. About your career perspectives, first of all is the scientific research profile that the university offers. This is by high-level mathematics courses, and this is in case you want to pursue an academic path and become a researcher. So this is a first possibility, but equally good are the possibility of going into financial mathematics and working banks, and another possibility is to pursue a career in software, cryptography, artificial intelligence. Data analysis is yet another possibility. As about applied research, obviously there is applied mathematics, which can be applied to as many disciplines as you want. For instance, take mathematical biology, which is now one of the main trends. And as already mentioned, education is yet another possibility that you can pursue after as a career perspective. And now I lend the floor to Yoli.
Ono. So hello everyone, my name is Ono Beddevoets and I'm a PhD candidate at Leiden University. I've been that now for a little bit more than 3 years, but right now I will go into some other things. So first, who am I? My family, you can see that on the right picture. Recently I also had a kid, so he's also on the picture, and we will plan to make him into also a great mathematician. My wife has studied mathematics, a master in Leiden. She did statistics, and I myself did algebraic number theory and geometry. As hobbies, I like to do some mountain biking or playing guitar. I also like to play board games. So let's continue to the next slide. Before my master's, I also did a bachelor in ProProduce at Leiden. My ProProduce I did in mathematics and physics. In high school, I also, at the end at most, I really liked mathematics and I also liked physics. So I didn't really know which one to choose. So I decided to do both and then see what studies I preferred more. In the end, I did like mathematics more, so I chose to continue my bachelor in mathematics and not continue the one in physics. Since the workload otherwise is quite big. In my bachelor in mathematics, I also did in Leiden and I really enjoyed that. I did some mathematical contests and it was quite fun. I also had a lot of friends here that I made during my bachelor's. That's also part of why I chose this master's here in Leiden. But I chose algebraic number theory and geometry. I really liked algebra, so I thought the proofs were really beautiful, and it was just to me it was aesthetically pleasing. So that's why I did this one. I also considered, I did not really consider doing applied mathematics anymore. Just because I like this one so much. I chose Leiden mostly because it's a smaller mathematical institution. I like that I could get to know most of the people, and also you get to know most of the professors or teachers. And in that way, I think it's more easy to, for example, choose a supervisor for your master's thesis. At least it's, I think, easier to just go by some offices and ask whether they have some topic for you that you're interested in. I also like Leiden because it's central. You can easily, as I said before, reach Amsterdam or Utrecht, which also has a lot of master math courses. And you also can go to The Hague quickly, or in Rotterdam. So that's nice too, I think. And as I said, during my bachelor's I made some friends, so that's also why I chose Leiden, for example. And of course in Leiden you also have a nice culture. Recently we had 3 October, for example, which is also a good reason to go to Leiden. During my master's I did some activities, of course. As courses I did, for example, algebraic number theory and analytic number theory, and those are master math courses. And I also did topics in number theory, which was taught here in Leiden as a master math course. Maybe it was, I don't think it was master math actually. And I really enjoyed the courses. I did not think that they were that the workload was too heavy or something. Actually, I think the workload was less heavy than during my bachelor's. So I chose mostly algebra courses. I also chose something like differentiable manifolds because I did want to try maybe a little bit of that, but mostly algebra courses and algebraic geometry 2, for example, or 1. For my thesis, I went to at the start of second year, I just went around to ask some people, some teachers or professors, whether they had something for me, and eventually, pretty soon I found something, so I could start early on that. That was nice. My thesis was about some Galois extensions of local number fields, of QP, of p-adic numbers. And then I did not consider abelian extensions, but they were almost abelian in some sense, but I will not go into the details of that. During my master's, I also participated in some programming coding competitions. I did that with some other people, other students that were also doing a master's there in Leiden. Then you start with, I think it's the LKP or something. That's a contest then that is hosted in each university, and also, for example, in Leiden. And then you go to the BAPC if you made it through. And I really enjoyed those competitions, and it was fun to cooperate together with in a team to figure out the programming puzzles. And that was really nice. In Leiden, I also was a teaching assistant during my master's for SPC. It's a course where you help students to learn how to give presentations, and also mathematical presentations on a blackboard, and how to write an article. I did that, I think, for 3 years, not all during my master's. I think that was easily to be combined during next to my studying activities. So as a work-life balance, I think it's, like I said earlier, I think the workload of a master's, for me, it was not too heavy. Of course, it depends on the courses. Some courses are require some more effort than others. For me, geometry was a bit more intensive for me because I found that more difficult. But number theory and such were a little bit easier for me. So in the end, I was not spending all of my weekends, for example, on studying. I had quite a bit of time for my hobbies that I like to do and for being a teaching assistant. After my master's, I decided to also become a PhD candidate here in Leiden. Some of those friends that I made earlier also became a PhD candidate in Leiden, so that's also nice. And also, of course, looked at other applications, but this year, made it through. Right now I'm a 4th year PhD candidate here, as I said before, and hopefully I can round it off. It will be my last year as a PhD candidate. My PhD candidature as a research topic, I am further investigating some things that I did during my master's. So right now I not only consider the almost abelian extensions of the p-adic numbers, but also of other local number fields, and that I did for my first 2 years. And then I found some explicit generators in certain cases for the extensions. And after that, right now I'm looking for the size of certain nilpotent extensions. As a PhD candidate, I'm also a teaching assistant in almost every semester. I mostly do the tutorials and edit some stuff on Brightspace, which is also fun to do. Mostly the tutorials. I really enjoy teaching courses. I also enjoyed that very much during my master's. So I talked already about my thesis, the nilpotent extensions of local number fields. And as a perspective after my PhD, I will either try to go into research, so I will apply to some postdocs, or I will go into, maybe something else. I think I will, also apply to some financial institutions maybe, or maybe, for example, ZBS, where my wife works. So that's the Central Bureau of Statistics. So I will make some applications and see what comes out of it. And I think that's that. So if you have questions, you can ask, well, the last slide did not appear, but you can type the questions and then we will answer these later. Then I will now give the word to Jolien.
Thanks. So hi everyone, my name is Jolien. I'm currently a PhD student at Leiden University, and I did the Applied Mathematics Master. So I'd first like to tell you a bit about how my master was like. So first of all, it's already a bit mentioned, but like if you do the master in Leiden, there's like this long list of courses you can choose from. They're all electives, so you can like kind of make your own program. So I would definitely recommend having a look at the website for both the local courses that we offer in Leiden and also for the Master Math courses. So I included this list of courses that I did, so you can kind of like have an idea what you possibly could choose from. But of course, this is absolutely not everything that's offered. So as you can see, I mainly did my courses in this field of dynamical systems, but I also did some in the Algebra Master, which is because I actually started with the Algebra Master and then I started thinking about what I wanted to do after my Masters, and I realized I actually wanted something that had applications in medicine, and then I realized it might be better to switch to Applied Mathematics. So that's how I got to this list of courses. And to my experience, most courses, as already being said, like people are very approachable. So whenever you come in, like the groups are quite small, so it's kind of easy to get in touch with everyone, and also with the teaching assistants and the teachers. Also, if there's a local course in Leiden, it's like very easy to just walk around the building, knock on someone's door, ask a question if you have questions, and it's just very easy to ask whatever you want to ask, actually. Then there are also the Master Math courses, which actually means that are courses for all universities or all mathematics universities in the Netherlands. So these are mainly in Amsterdam or Utrecht. So for those, you mostly like go to Amsterdam or Utrecht, follow the courses there. So then it's a bit less easy to just walk around, but then in my experience, it's still very easy to just shoot someone an email and ask your question, and they always reply quite fast. So it's still quite easy to get in touch with people. So after me having done all these mainly dynamical systems courses, I decided I also wanted to do my thesis in dynamical systems. So I also just went to some people in our dynamical systems group in Leiden, and I ended up with Herman Jan, who is a professor at the dynamical systems group, and we went to do something with spiral waves. So I would shortly like to tell you a bit what this is. So our title was Stochastic Effects on the Angular Velocity and Translational Displacements of Spiral Waves, which is a very long title, but I'll try to at least give you an impression of what we did. So we wanted to look at spiral waves because that's something that, well, if you just look around in nature, you see it a lot. So we have like plants, shells, snails, but also on the bigger side, there's like this galaxy thing, there are whirlpools. There's this thing with all these animals in the sea that kind of form a spiral. And then there's also the picture in the middle, it's spiral waves in heart tissue, which actually where our motivation comes from. So normally if the heart beats normally, it just contracts in this way that pumps all the blood through. But sometimes if you have heart arrhythmias, it doesn't pump normally, but actually the cells contract in this kind of spiral wave shape. And we wanted to, well, kind of investigate what was going on there. So the idea is that you have these rotating spiral waves that all have a rotation speed, and they can translate, so they can move to the left or the right, but also up and down. But normally what we do in mathematics is we kind of consider it as being perfect, so we make this model that describes the spiral wave, but then it doesn't really fit the things we see in nature, because in nature there's always this kind of insecurity and actually the noise. So we wanted to add the noise. And if you do so, you have these models that you can actually kind of add stochastic terms to. And then we wondered, okay, how does this noise actually influence this rotation speed and also the translations of such rotating spiral waves? So I included an example of a specific model. So this is only a deterministic model, the Berkeley model. And then what you just do is you add a noise strength and kind of like a stochastic term. So how does this look like? Well, on the left-hand side, you see this figure of a deterministic spiral wave. Let's see if the movies work. Yeah. So you see it moving right now. So the orange part is where the spiral wave like equals 1, and then blue is where it equals 0. So the orange thing is actually the spiral. And indeed, you see it moving around. You kind of have to trust me now that it's moving around with with a constant speed. And also the center of the spiral actually stays at the same place. So now the question is, if we actually apply noise to this, then this is an image or a video with space-time white noise, which means that for every pixel on the screen, for every time step, you throw a dice, and whatever is on the dice is the noise you use for that specific place and point in time. And if you have seen them together, you can see that this spiral actually rotates much slower than the other one. So what we tried is we kind of decomposed the stochastic spiral into like the deterministic part and the noise, and then we actually, after a lot of work, could find a very implicit or explicit formula that shows the average neo-rotation speed and also the translations. And then we found that the difference between the stochastic spiral wave and the deterministic spiral wave, and also the difference between the stochastic angular velocity and the deterministic angular velocity, they're only seen at order sigma squared, where sigma is this noise strength. We thought it was quite a cool result that you can do with dynamical system theory and some stochastic PDEs, but I have to say I didn't do anything with stochastic PDEs before I started my master's, or actually before I started my thesis. So even during your thesis, there's still enough time and space to like learn about new subjects that you can use or that you can need there. So what do I do right now? So I'm currently working as a PhD student in a dynamical systems group in Leiden again. We're looking at 2 projects. So the main project is about these vegetation models. There's a huge group in Leiden working on vegetation models. So like if there's an area where there's not enough water supply, then not the entire area can be vegetated, but instead you get these patterns. So like vegetation can go into stripes or spots or like make gaps. So that's what we're looking at. And then our specific question is like most of the models so far assume that the underlying terrain is flat, or just sloped. But we wonder, what if the underlying terrain is not flat? Because normally these large areas with vegetation are not in the Netherlands, but like in Africa or United States, in places where we actually have hills and mountains and all other types of variation in the terrain. So we want to know what happens if we have this pattern, so the vegetation pattern, on top of another pattern, and the other pattern is in this case the spatially varying terrain. And then there's another project starting up, which is again about things in heart arrhythmias. It's together with people from the LUMC. And so they found that in case of heart arrhythmias or cardiac fibrillations, it sometimes can happen that these arrhythmias stop simultaneously. And now we want to know what makes this sudden stop possible, because if we can find that, then they can also change the treatments for people, so it's like more efficient to prevent heart arrhythmias from being there. So it would be really cool if you can find something and also like change the treatments to help people better. And with that, I would like to conclude my part. And so for now, there's gonna be a Q&A.
And yeah, so feel free to ask the questions anytime. And we'll discuss these questions now. So it's for the Dutch-speaking people here.
So the question is, ik heb de lerarenopleiding wiskunde afgerond. Ben ik dan ook toelaatbaar tot deze opleiding? I would say it's maybe easier, depending on which specialization you want to do, to send an email to either Martje or Dalia about this is about the entrance requirements.
Yes.
So like for these specific ones, I'm not very sure, but they can definitely tell you if you just explain a bit like what exactly you did.
Yeah, and in the end of this presentation, there will be a slide with additional information and links, and those will be also helpful to find information about the programs which we offer in the master level at Leiden. Yeah, so the next question is about what percentage of maths master students are international students, and whether there's any advice for international applicants. In general, if you are an international applicant, you can just apply to Leiden. What you need is a diploma which is equivalent to a Dutch diploma, and most European and international institutes have basically the same diploma as a Dutch diploma. You can check again online the requirements. As an international student, you also need some English requirements. You need to speak a decent level of English. Many students also come with a 2-year program where they spend 1 year in Leiden and 1 year somewhere else. For instance, if you do the Algond program, then you spend 1 year in Leiden and 1 year in the other 10 possible universities, and it can be in Canada or China or South Africa or other countries in Europe. And for the percentage of the math master students, I would say that it's roughly half.
Roughly half, yes.
I don't know what your experience is about it.
I have to admit that I did my master's mainly during COVID, so I actually have no idea how many we were. But
as I look at the master math class that I'm teaching, I think that about, 40% of the students are international.
Yeah, I think that's
yeah.
reasonable.
Yeah.
And maybe one more advice for international applicants is that the Netherlands is not a big country, meaning that you don't need to live in Leiden to travel to Leiden. So you can live in Amsterdam, or you can live in The Hague, or you can live in Utrecht, and you can just travel to Leiden when there are courses. And also, as it was said, some courses or most of the courses are offered in Master Math, which is a nationwide program in Netherlands. And mainly the courses are taught in Amsterdam and Utrecht. And no matter what, you have to travel around to go to these courses. But the main point what I wanted to make is that you have a choice. If you prefer big cities, you can go to Amsterdam and live there. If you like gorgeous smaller towns, then you can come to Leiden or some neighboring towns in Leiden. It is your choice. So the next question is whether there's a requirement of level of English. I know that there is, but I don't know
what exactly is. I do not know, but they are required to have a certificate for English. You can email us for this question and we can answer it.
Can I add something? So this is only for the international students, because like for Leiden, if you're a Dutch student, then they normally don't ask you about this, because like if you finish Dutch high school, your English proficiency is, your English is good enough. So.
Yes, I assume that this is for international students actually, yes.
Seeing the name.
Yeah, and you can also hear us speaking, and we are not from the US or from England. We are not native speakers either.
Yes.
The next question is whether there are internships possible during your master. I do not know the answer.
I do know that in the past this was possible to have 1 year abroad. So doing a year in Leiden and 1 year abroad at one of the chosen university, like in Paris or some other universities in the list. But whether this is still in action now, I do not know. This was last year.
Yes, so far as I know, it's not something that's normally offered, like internships. So there's a difference between studying abroad and internships, I guess. So studying abroad is still a possibility. Internships, it's not something that people normally do, but I think last time I spoke to people about this, you can do it, but you have to arrange everything yourself, and then you have to go to the exam committee to actually get, acceptance for that. So you can, but it's like not something that we normally offer, so you really have to like make this or do this yourself.
So the next question is, what is the difference in research orientation between Leiden University and Utrecht University in the field of arithmetic, algebraic geometry? Is there a reason to choose one university over the other? These are always good questions. Which university to choose in the Netherlands is especially a difficult question because of the Master Math program, that many of these courses are offered nationwide, and basically if you join Leiden or Utrecht or Groningen or Amsterdam or Eindhoven or Delft, then basically, or Nijmegen, then basically you have the same courses to choose from. I don't really have a good answer to this question. What I would say is that you can look at the profile of the people at the universities, and you can talk with them. At Leiden we have this open door policy that we usually keep our doors open, the office doors, so people can just come in and talk with us. And that applies in general, that you can send us also emails, and we try to respond as well as possible. So my advice would be to look at the profile of the people, ask some questions from them, what their research interests are, what would they think as a master thesis project, and then you can decide what you would like to do. So which email address can one send one's questions about language levels and recognition of tests and certificates? So there will be a slide in the very end about information and links. There's also information online, especially about language levels and recognition of tests and certificates. You can send us an email. We don't deal with these kind of questions. We are study advisors. We help the students to so here you see the information, but the point is that our job is to help the students to choose courses, but you can send us an initial email and we can send it to forward these emails to the appropriate people at our department.
Admission committee, that's basically we talk to them.
Yeah, so this is basically the admission committee, and you can also find the link online for them. But if you cannot find this information, just shoot us an email and we'll direct you to the right person.
That was it for now.
Okay.
So that was it for now, and then we can have the last slide and
Should I do that?
so we good?